Okay, coefficient of variation expresses the standard deviation as a percentage of the sample or population mean. So it's used to compare measurements from different population. Your answer is going to be a percent. So depending on if you have a sample or a population, you're going to take your standard deviation divided by your mean times 100. So every time it's always going to be standard deviation divided by your mean times 100. So here we have the trading post on Grand Mesa is a small family-run store in a remote part of Colorado. The Grand Mesa region contains many good fishing lakes, so the trading post sells spinners, a type of fishing lure. The store has a very limited selection of spinners. In fact, the trading post has only 8 different types of spinners for sale. The prices in dollars are given there. Since the trading post has only 8 different kinds of spinners for sale, we consider the 8 data values to be the population. So we're going to find the population mean, the population standard deviation, and it says using your calculator. So that means we have to type our numbers into our L1. So remember, we're going to hit our stat button, and we're going to go edit. We're going to go up, hit clear, move back down, and type them in. So I have 210. Again, always double check you type all of your numbers in correctly when you go through these two. So now what we're going to do is hit our stat button again. We're going to go over to calc. We want the one var stat, so we're going to hit enter, and we're going to move down to calculate. So there's all of our numbers. Now we are talking about dollars here, so we're going to have 2 decimal places when we write everything out. So our X bar is going to be 2.14 because it's going to be $2.14. Standard deviation. So for our standard deviation, we want the sigma X on our calculator. So the sigma X is going to be then 0.22, so 22 cents. Now they want you to find the coefficient of variation. So you take your standard deviation divided by your mean, multiply by 100. So 0.22 divided by 2.14 times 100. And we get 10.28%. So if we have a smaller standard deviation, it means the data values are closer together. If you have a bigger standard deviation, it means the data values are more spread out. So since we have 10%, so it's saying the standard deviation is 10% of our mean. That's very small. So because that percent is very small, we are saying the selection is priced very similar to each other. And again, that's because our coefficient of variation is a smaller percent. The smaller percent, the closer that means for your standard deviation. So that means it's not going to be varied as much. So for number 7 here, I want you to go through and do the same thing, except now if you read it says sample. So you are going through and you're doing the sample mean and the sample standard deviation using your calculator. So pause the video, complete A and B. We can look at C together, that's fine, but complete A and B on your own. Okay, so you should have something written down for your A. You typed all of those data values in. There were 10 of them. And you put them into your L1. And then you found your 1-var stats. You should have for your mean 1.87, so $1.87. For your SX, not your sigma X, but your SX, you should have got then 62 cents. So if we divide those two and multiply by 100, we should get 33.16%. Now that's a higher percentage. So that means then those values are going to vary more instead of the smaller store where the numbers were all closer to each other. So the bigger the percent, they're saying the more varied the numbers are going to be. So if I look at these values then, we would say the smaller store has a smaller variation since it has a smaller selection. Whereas the bigger store is going to have a bigger selection, so that means the numbers are going to vary more. That's why we have a higher percent. The last part of this section is Chebyshev's theorem. And this is going to be a way to say how much data falls between intervals. So if we want at least 75% of the data, we're going to have mean minus 2 times sigma to mean plus 2 times sigma. If it's 88.9%, instead of a 2, it's a 3 for both of those. And then for 93.8, it's going to go 4 for both of those. So if we want to have 75% of the data, we have to figure out the range between what two numbers that would fall. So if we look at example 8, you need to know what your mean and your standard deviation are. So they tell us 75%, so that means we're going to take x bar minus 2s, or we're going to make that then x bar plus 2s. So my x bar is 29.1. My s is 1.7. So we're going to plug those in to figure out what that range is going to be. So we have 25.7 hours to 32.5 hours. So we are saying then for this problem, because we're looking at volunteer hours in a semester for college students, at least 75% of the students would fit into the group that volunteered from 25.7 hours to 32.5 hours each semester. So we're saying at least 75% of the students would volunteer between 25.7 hours to 32.5 hours. Now going to number 8 here, I want you to try this one on your own. So you're going to hit pause and go through this for the Chebyshev interval of 88.9%. Okay, so you should have a value for the minus and the plus. Hopefully you saw that it was 88.9, so that means it should be a minus 3s to plus 3s. Your x bar was 525. Your s is 30. So again, you type those into your calculator, and you're going to get 435 responses to 615 responses. So for this problem, we would say at least 88.9% of the subscribers who read the classified section each day would fit into the group of 435 to 615 responses per ad.